Alright, so in this video we go over the last two examples we didn't get the chance to do in lecture. So those are examples 4 and 5. So for example 4, we're going to have one of those examples in which the u is no longer going to be x, but rather in this case it's going to look different. So we're going to have in this case a to be a is going to be 3, but in this case u no longer x, that's 5x. Okay, so from here, well, if we look at the form, this one form looks exactly like case 1, in which the expression is of the form radical a squared minus u squared, whose substitution will be u equals a sine. So let's set the substitution u equals a sine theta. So u, which is 5x, equals 3 over sine theta. And x equals to 3/5 sine theta. From here we are going to find the differential dx, 3/5 sine theta d theta, and from here, or rather from here, we are going to solve for the trigonometric function, and in order to build the right triangle that will set up the trigonometric substitution. So recall that this is the opposite and this is the hypotenuse, because that's the definition of sine, opposite over hypotenuse. That's 5x over 3, and the missing side is the radical expression, square root of 9 minus 25x squared. Alright, also we need another piece of information. So this is 1, this is 2, and number 3, we need the quotient between the radical and the constant term. And that is the square root of 9 minus 25x squared over 3, which equals adjacent over hypotenuse, and in this case that's the cosine function. And solving for the radical, that's 3 cosine theta, and that's number 3, the 3 elements that we need to set up the integral. So let's go up here to the integral. Okay, so for the integral, so what's x? Quantity squared. So in this case x, which is 3/5 of sine theta, quantity squared, over the radical, the x, and the radical, which is 3 cosine theta, times dx, which is 3/5. Actually, I did a mistake here. This is supposed to be cosine theta, not sine theta. And this is 3 cosine theta d theta. And that's the integral of this, the integral of all that. So let's see, how can we reduce? In this case, I'm going to cancel the 3 with another 3, cancel the cosine with this cosine, and all we are going to be left, okay, let me take this 5 in the denominator outside of the integral as 1/5 times the integral of, okay, raise this to the second power, 3 squared, which is 9, 5 squared, which is 125, sine to the second, which is sine squared, theta and d theta. Okay, so yes, this integral is going to look simpler. I believe it's going to be simpler than it actually looks. Okay, So what is this going to be? Okay, so 9 over 5 times 125, and I believe this is going to be, where's my notes? Well, it's not 125. This is 25 actually, and 5 times 25 is 9 over 125. Sorry for this couple of mistakes. Sine squared theta d theta. Okay, so in this case we're going to use, to integrate sine squared, we're going to use the power reduction formula right here. Or, well, it's actually called the half angle formula, but I call it the power reduction formula because we go from square to linear and we get this. So 9 over 125 times the integral of 1/2 1 minus cosine 2 theta d theta. And then from here, you know what, let me go all the way here. I need more space already. Let me go up here. So this will be 9 over 125 times 2, isn't it? 250. And this is 1 minus cosine 2 theta d theta, which equals to, in this case, let's split it into two integrals. And while these two integrals seem very straightforward to evaluate, the integral of the theta is, in this case, simply theta, 9 over 250 theta. And then the integral of cosine 2 theta, well, minus 9 over 250, is sine 2 theta times 1/2. This 1/2 comes from integrating cosine plus c. Okay, so in this case we're done with the integration. Let's do now the back substitution for the trigonometric function. So in this case, well, for theta, in this case we can use this definition here. Where is it? Well, actually right here, from sine theta equals 5x over 3, and find arc sine on both sides. So we've done that before on other exercises in class. However, I'm worried about the sine 2 theta. Well, let me simplify this first. And this sine 2 theta, okay, be careful with this sine 2 theta because, and I would pay special attention to this, we cannot use this triangle right here to simplify sine theta in terms of x, because this triangle right here is only for theta, not for 2 theta. So we will have to use another trig identity, which is the double angle in this case. Sine 2x equals 2 sine x cosine x. Well, in this case, we're using theta. And now we are ready to simplify this. So number one, from here, take it there, find inverse sine on both sides to get theta equals to arc sine of 5x over 3. Alright, so that's going to be our theta here. So 9 over 250. And instead of theta, we're going to go arc sine of 5x over 3. minus, okay, again this 500 will become a 250 because 2 over 500 goes into 250 in the denominator. And sine, what is sine here? So let's do sine and then let's do cosine. So from the triangle, sine, which is opposite over hypotenuse, that's a 5x over 3. 5x over 3. And cosine, adjacent over hypotenuse, or we already have it here before, so that's the square root of, what is this? 9 minus 25x squared over hypotenuse, which is 3. So this is what's going to happen here. A lot is going to happen here in this case. This 3 times 3, which is 9, cancels with this 3. And 5 over 250, it's going to take us back to 50. Alright, 50. And then don't forget the plus c. Let's keep simplifying this, rather cleaning up. 9 over 250, arc sine 5x over 3. And then over here, we got in the numerator, we got x times the radical. And in the denominator, the only number that survives is the 50 plus c. And let's call it a final answer here. We're done with this one. All right, let's do the next example, example 5, or rather the last example. Example 5, which in this case is, it has a different format than usual in this case, and so it's not in the form a squared plus u squared, or u squared minus a squared, or a squared minus u squared. Well, it's not in any of those formats. So this is what we're going to do. We're going to play with this polynomial right here, x squared plus 4x, and then, well, in this case we are going to complete the square. This is what we're going to do. I'm going to add one number, a magical number that completes the square, and then plus 8. Right? And then if I add a number, I need to subtract that number. All right? So what is that number going to be? That magical mystery number, call it m. It's going to be the coefficient of x, which is 4 times 1/2, and square that number. So 4 divided by 2, which is 2, and then 2 squared equals to 4. So 4 and 4, all right? Now, so in this case, if we keep going here, this right here will be the perfect square trinomial. X plus, well, actually I had a different number, but never mind. I'm just gonna leave it like this. X squared, well, not x squared, it's just x plus 2 quantity squared, and 8 minus 4, which is 4. So in the end, we're gonna have the integral of the square root in the denominator of the quantity x plus 2 squared minus 4. 1 dx. And if you look at the form, this is u squared minus 4. So in this case, this is the u, and u equals x plus 2, and from here a equals the 2. Okay, so let's see, let's set up the substitution where u, okay, first of all, which substitution are we going to use? Well, actually this is supposed to be positive and positive, okay? So in this case we have the both positives. The substitution that calls for both positives is like the case 2. Square root of a squared plus u squared. Substitution is u equals a tangent. So in this case the substitution will be so u equals a tangent theta, where u equals x plus 2 and a equals 2 tangent theta. Alright, in this case, so up to this point you haven't seen anything like this. So before you only had like x's or x times a number. In this case we have x plus a number. Let's just subtract. And then from here, let's find the differential dx, which is 2 times the derivative of tangent, which is secant squared theta d theta. And in this case, to build a triangle, solve for the tangent function. Tangent equals to x plus 2 over 2. Okay, now let's see what we get. So from here, let's build a triangle. Theta. And again, this whole numerator is going to be the opposite, and this is going to be the adjacent. So opposite, which is going to be x plus 2 over adjacent, which is 2, and the radical form will be the hypotenuse. All right, and then so let's do the u substitution. In this case we're ready to go. So let's go back to replace the radical. So let me see if everything is going to fit in here. No, it may not fit. Well, we need an expression for the radical still. So this is x, which is number 1. We're not going to use it this time. Number 2, the differential, and number 3, radical over radical over 2, which equals the trigonometric function that describes this is hypotenuse over adjacent, that's secant. So the radical form, or the radical term, will be replaced with 2 secant theta. Okay, so that's part 3. So the radical will be the integral of 1 over 2 secant theta times dx, which is 2 secant squared theta d theta. Okay, so over here, what are we going to end up with? This one is going to go a really simple integral. So the 2's cancel, and 1 power of secant also gets canceled. Let me continue over here. So all that remains is simply the integral of secant theta d theta, which is ln of secant. We have used this formula before in class. Plus c. Now we need to use the triangle to find the definition of secant. Well, we already have secant here, which is the radical over the constant. Over the constant 2 plus tangent, which is opposite over adjacent. And this is the end of the integration. All right. So what was different about this problem? The difference about this problem is that in this case you had a trinomial. You need to complete the square first. You need to complete the square in order to make this look like the integral of the square root of u squared plus a squared. And then from there, determine the type of substitution, because from here we cannot just tell what the substitution will be. So this was the end of the video, right? So I'll see you in class, I guess.